The last type of question that we're going to go through, at least in the notes here, is something, or it's a type of equation that we're going to call graphic form. Okay, so all linear equations that we come up with, anything that we look at, can always be written out in graphic form. Okay. We also call this, we have another way, it's called slope intercept form. I'm not going to go through that with you. You'll deal with that in grade 10. You look at slope intercept form. But we also can call it graphic form. It's a way to graph things out really easily if we want to. This is, in this form, okay, it's what happens when y is isolated on the left side of our equation. There we go. Okay, so it's y is isolated on the left side. You'll notice here we have the equation looks like this: y is equal to mx plus b. That's what we call graphic form. Again, we'll take that more up in grade 10 when you get there. But for now, we're just going to deal with how can we use that to write an equation. This equation right here, the m and the b are going to be numbers. The y and the x are going to stay exactly as they are as variables. So I'm going to put that in here. The x and y are the two variables. These will always just stay put exactly where they are. Y will stay on the one side and X is going to stay on the right side. Okay. So they're going to stay put exactly where they are. Um, we don't move them at all. Okay, we just leave it Y here, X there. We're going to adjust the M and the B in there. All right, then we're going to take a look at the M. Okay, the M. And so that's going to be it's going to be a number. Okay, it's m right there, but it's going to be a number. This is called the slope. Okay, again, we're going to deal way more with slope when you get to grade 10, so we're not going to worry about that too much. But it's how the value of y is changing as x goes up by 1. So as our x goes up by 1, how is the y changing? If we look at a table of values, okay, we've looked at that in the past. The x often goes up by 1, and then we take a look at how the y is going up. That's our m, that's our slope, okay? And that's going to be put into our equation, okay? We can also call this the rate of change. Okay, so that's another way to kind of think about it. It's the rate of change. It's how is something changing based on time. Okay, so that's or oftentimes sometimes it's something different, but it's the rate of change. How is something changing uh, based on how if the values are going up? Okay, so that's the M part, and that's important that we catch that. Now the last one here, this B, okay, B is the starting point. Okay, so this is the starting point. This is where it all begins. If this is like a question of climbing or earning money, it's how much do you have right at the beginning, right? Like, what are you starting with? What are you beginning with? Where are you beginning? If it's like a height question, where are you beginning? It's the point when the x value is 0. It's that starting point. Often in a graph, we don't deal with it, but or sorry, in like a table of values, we usually start with like 1, 2, and 3. But it's actually that first value. It's that initial value. Okay, so we could deal with something that looks like this, and if we recognize that a question deals like with this, then we can use this equation right here. Now, to understand this pattern, okay, it's sometimes very helpful to make a table of values. Okay, so to recognize the pattern, we can often make a table of values. Okay, to kind of recognize what we are doing with that solution. Now, I don't say you have to because if you can recognize it, unless I absolutely demand that you do, you don't need to, but you can definitely use a table of values. Let's look at a few examples again. So the first one here says is a plumber charges a flat rate of $40 plus $30 per hour worked. Determine the total cost for the work done. So this is actually a very legit question. Let's say that you have a, well, maybe not the numbers, but at least somewhat. Let's say that you have a plumber that's going to come into your house and do some work. Okay, something needs to get fixed, a pipe burst, or you have some work needing to be done in your house. Okay, what they're going to often do is they're going to come and they're going to charge you a flat fee. Okay, they're going to say that just for showing up at your house or even for leaving the office, they're going to charge you 40 bucks. There we go. That they're going to charge you right off the bat, no matter what. Doesn't matter how long they stay at your place, they're going to charge you a $40 flat rate. This is our starting rate. Before they've even started, that is what they're going to charge you. That's our M. The second number here is how much they charge per hour worked. Okay, this is our rate of change. For every hour that they work, they're going to charge you 30 bucks. This is our M. Change it here. This is our B. I'm sorry. There's our starting point. This here is our M. This is our rate of change. Okay, there's our slope. That's our rate of change. Now, what we can recognize as well is that this rate of change is based on hours worked. Okay, so hours worked has to be one of our variables. Okay, and in fact, it's going to be our x value. It's our dependent or independent variable. If we look here, m is being multiplied to x. M is how much we charge for every hour work. So we're going to be multiplying that to, so x is going to be the number of hours worked. Now, in a question like this, the y value is always going to be our final answer. Okay, in this case here, it's going to be the total cost of the job. Okay, it's the total cost of the job. It's this y value on the outside that we find. Okay, right here, it's the y value. So it's going to be the total cost. And this says determine the total cost for the work done. Well, that's y. Okay, y is going to be the total cost. Now, in this question here, when we come up with an equation, okay, we're going to follow that y is equal to mx plus b right here. That's the equation we're going to follow. So y is the total cost of the job. So we're going to do y right there. All right. Now m we said was how much it's changing, and for every hour it changes by $30. So we put 30 in there and we multiply it by x. So we do 30x, and then we add our starting point, which was 40. So when the plumber comes to your job, he's going to say that he's going to determine how many hours he worked. If he works 3 hours, okay, x then is 3. That's how many hours he's worked. It's going to cost you 30 times 3 plus 40. So that could be one of our solutions. And let's put that in as a solution. I apologize, this program is kind of slow, but I still like the way that it works. All right, solutions. So if x equals 3, okay, so that means 3 hours worked, we plug that number in here, right? So the plumber's going to plug it in, and he's going to say 3 times 30, it's going to be $90, plus 40 is 130. So y is equal to $130. For 3 hours worked, they're going to charge you $130. Let's say this is a bigger job, okay? So let's say that instead of only spending 3 hours there, he spends 10 hours there. Well, you'd expect that he's going to charge you a little bit more, right? 30 times 10 is 300, plus 40 is 340. So it is $340 for the job. Okay, so Y, total cost, X, number of hours worked. And this is in our graphic form or slope intercept form. Well, don't worry about that name. Call it graphic form. And as long as we see a rate of change and a starting point, we can go from that. All right, number 7 here. So our next example says that an airplane starts at a height of 5,000 feet. Oh, wait a minute. Starts, begins. That means that must be our starting point. What was our starting point again? Okay, here 5,000. Starting point is always B. Okay, and now it descends. So it is going down. Descends means going down 20 feet each minute. Whoa, that sounds like a rate of change. So that is going to be our M. Okay, that each minute means it's a rate of change. It's going to be our M. Now, if we're going down, okay, I'm going to just quickly write that in. You can barely see it here. That means that this is going to be a negative. So we have to remind ourselves that that's a negative. The height's still a positive, but that one's going to be our negative. All right, what variables are we dealing with in this case? Okay, well, here is our rate associated with each minute. So that means that X has to be the number of minutes traveled. Okay, it's going, right? It's number of minutes traveled. Again, when we start at 0, it's gonna be B. Okay, so that's where we start. But it's kind of number of minutes traveled, I guess, since we start descending. Y then is the current height of the airplane. Right? So it's the current height of the airplane. So when we know this, then when we find our solutions, we know exactly what each number represents there. So x is the number of minutes traveled, y is the current height of the airplane. So when we put that in here, said that m was 20, but again, that is negative 20 because we're going down. So negative 20x plus the 5,000 feet of where we started. And that's going to be our equation. Okay, negative 20x plus 5,000. Now it's a going down feature, and so we have to recognize that we're going down. And so if we come up with some solutions here, let's say that 10 minutes after we start, so let's say x is 10. I'm coming up with numbers for the x. Now we plug 10 in here. Negative 20 times 10 is negative 200 plus 5,000. That means that y, it's going to be 5,000 minus 200, is going to be 4,800. Okay, so 10 minutes after, the plane is now at 4,800 feet. Okay, if we jump up and make this a little bit bigger, let's say 2 hours later, so 120 minutes. Okay, 120 times 20 is 2,400. Okay, y is then so 5,000 minus 2,400 is going to be 2,600 feet. Okay, so 120 minutes in, it's 2,600 feet. So those are some solutions. Again, each one of these is a single solution. Last question that I'm going to go through with you, and then you'll have your assignment to work on, is number 8. Okay, number 8 is a paid one. Okay, it's an earning wage. It says that Rhonda gets paid a commission of 25% on all her sales. Now, we only have one number. Okay, the one number that we have is this 25% right here. Okay, 25% of all her sales. So it's on her sales. So that means that this has to be our rate of change. Okay, this has to be M. The starting point is not given. So if the starting point is not given, what do we start with? Well, if it's not given, it's a 0. Okay, so our starting point is definitely 0. Now, what are we solving for? Well, what we're going to be given, okay, what we're basing this all on is her sales. Okay, so her sales is what we're basing it on. So X is going to be the value of sales Rhonda makes. Okay, the value of sales Rhonda makes is going to be our X. Okay, that's what we're starting with. Okay, she's making sales, 25% of our sales. So we're going to multiply by 25%. Okay, that's going to be the value of all our sales. Y then is going to be the amount of money she makes. Okay, how much she gets paid. Okay, I can put that into brackets. What's the amount of money that she gets paid? Rhonda gets paid. How does she get paid? Based on her commission. Okay, 25%. Now, how do we put this into a slope question or a graphic form question? Well, we have M, it's 25%. Y equals, now 25%, we don't write it 25%, we need to write it as a decimal. A percentage as a decimal, we just divide by 100. So it's going to be 0.25x. Now, our starting point was 0. If she doesn't sell anything, she makes no money. Okay, so that means her starting point is 0. So we need to add 0. Well, we don't actually have to add 0. We could, but that doesn't change anything. So we can actually just get rid of that. We can just say y is equal to 0.25x. Okay, and that's how we can come up with our equation. So this is our equation that we are coming up with. Now, what would this mean for a solution? Well, the first thing we do, and this is remember where I would ask you in class, we should come up with some x values. Let's say that she sells $1,000 worth of merchandise. Well, if we put $1,000 in there, so 0.25 times 1,000, that's going to be 250. So if she sells $1,000 worth of stuff, she makes $250. But Let's say here, if she sells $0 worth of stuff, okay, 0.25 times zero, her amount she gets paid is zero as well. So again, this is how we come up with a solution for that. Your assignment, okay, on the next page, I want you to work on questions 2 to 4. Question 1 was just coming up with solutions. Okay, questions 2 to 4 are coming up. Or sorry, question 1 was just coming up with defining our variable and coming up with that. Questions 2 to 4 ask you to actually come up with the solution. So for 3 and 4, I want you to define your variables. For number 2, you're just given an x. You're kind of just told a number, so that's just going to be x. You can define that if you want, but once we get some more context, then make sure that you define it.